So, the rare earths and often accompanying strategic metals. Anyone who's been around watching this channel for a while, you've heard me mention them more than once, often in every episode. When I list each one off, I always tend to try to include a few of their more predominant, more well-known uses. However, each and every one of them is used for more than just the few things I rattle off in each weekly energy and resource update episode. So sit back and get ready. We're now going to go through the rare earths and strategic metals and actually list out each of their uses. So beginning with almost certainly the most well-known, neodymium. Neodymium is an extremely strong magnetic element, as are many of the rare earth elements actually, as you can see demonstrated here in these two items, the samarium resonator magnet from inside a headphone, and the either neodymium or samarium rotor from inside a small electric motor. You can see just how small of a surface area the end of the rotor is, but it is still able to be held together by their magnetism, even by such a tiny surface area. So because of its strong magnetism, neodymium finds its most predominant use, as mentioned in regular episodes, electric motors and in wind turbine generators. Now, neodymium tends to be used in larger electric motors, predominantly those used in electric vehicles and hybrid vehicles, as well as those used in servo motors for factory equipment, and in a non-motorized magnetic form, it is also often used as the primary magnetic material for the resonator inside of speakers, some headphones, although headphones tend to use samarium, and microphones. So the rare earth metals, particularly neodymium and samarium, are what allow us to actually record and generate sound. Now, not just neodymium, but most of the rare earth metals are needed in some way in all the different kinds of lasers, the different colors, different wavelengths, different strengths. Neodymium in particular is a bit specialized. It's needed for infrared lasers. Lasers are used for precision cutting in many modern-day manufacturing processes. Broad lasers are used to scan things, to get precise down to the nanometer measurements. And, particularly in the case of infrared lasers, lasers are used for security measures, whether it be home security or security for commercial buildings of any kind. Why infrared? Well, because it's low energy, it doesn't take a lot to produce it, and because the would-be intruders, you, can't see infrared. And neodymium is also added to the molten mix in the making of special glass, different types of glass used to filter out different types of wavelengths. Dysprosium, also first and foremost, its greatest use is in electric motors and in wind turbines, as what's in there is almost never pure neodymium, because when any of the magnetic rare earth elements are used completely pure, especially in an environment where they're going to be moving all the time, they can be a bit brittle. However, that changes when they're alloyed with each other, and specifically with each other because you don't want to alloy them with other stuff, preferably at least because you don't want to sacrifice any magnetism. So when you add usually about 6% dysprosium into the mix, then you get a very strong rare earth metal alloy that maintains the same strength of magnetism as well. Sometimes the mix is higher, sometimes it's lower. For example, in wind turbines, the particular mix by weight is about 400 pounds of neodymium and 60 pounds of dysprosium per megawatt. Dysprosium is also very critical for the functioning of computer hard drives. See, on the hard drive disk, down at the nanoscopic level, there are individual little nanograins that are either flipped up or down magnetically to signal 1 or 0. And since they have to be magnetically as sensitive as possible, they obviously have to be made out of rare earth elements. And the particular best mixture we found is a alloy in the grains of dysprosium and gadolinium. Dysprosium is also used in the special material to make many different types of transducers, which are instruments used across all fields. They convert any particular type of energy you have them set to measure into electric signals that a computer can then interpret. One of the examples most immediately always brought up is ground deformation sensors, used both in and around volcanoes to monitor rising or falling of the ground, and as modern earthquake monitoring. But they can be and are used for all kinds of other things as well: hydrophones, depressurization monitoring, and dysprosium is included in the alloy mix of various types of nuclear control rods, as well as various types of radiation shielding material. Terbium, a bit rarer, a bit more expensive, is also used in electric motors and in wind turbines, although its magnetic alloying component is a bit smaller. For example, for each 1 megawatt of, still using a wind turbine example, it's about 400 pounds of neodymium, 60 pounds of dysprosium, and only about 15 to 30 pounds of terbium. The amount of terbium can vary based on the amount of praseodymium also being used. Terbium is also used in computers, however in a different manner. It is a dopant material added into the silicon wafers used for flash memory, solid-state memory, and RAM. So although each individual computer, phone, or what have you contains very little in the way of nanograms, terbium is critical to that function. And it was once a phosphor in old CRT TVs and CRT computer screens. However, now those are on the way out. However, it is still also used as one of the tricolor pigments for our now modern flat LCD screens. However, the amount used in modern screens versus old CRTV screens is much, much smaller. Gadolinium. It is, as already mentioned, used in a combined microalloy with dysprosium for the magnetic grains on hard drive disks. It is used by itself for the larger magnetic grains on regular CD disks and Blu-rays and other things of the sort. It is also a component of the electrolytes of many fuel cells, many of which power spacecraft and satellites and the like, which are very important to the functioning of our civilization, the satellites, and the furthering of our civilization, the spacecraft of various kinds. Gadolinium is also one of the magnetic materials used in the making of the superconducting magnets for MRI scanners. And even on a more commonly seen, not as recent invention, X-rays, as it is a critical component in the X-ray sheets, along with several of the other rare earth elements. And although we have not found anything in particular to do with them yet, gadolinium is also one of the critical materials needed in neutrino detectors. Now, moving on to the just priorly mentioned praseodymium. It is also, once again, used in motors and wind turbines, in about the same minor levels of addition or concentration that we mentioned terbium being at. It is also one of the two critical components of didymium glass, which is the eye shielding or light blocking glass used to be able to look at really bright sources of light. The most common use of it being in welders' goggles or in the visors of welding helmets. It is also used as a alloying component, typically between 0.01 to 0.02% in various magnesium alloys that are used for the parts of all kinds of different aircraft engines, from jet engines to turboprop engines to helicopter engines, what have you. It is also used as an alloying component in the various metal alloys used in supercooling refrigeration, i.e. the type of stuff used to, cool down and contain liquefied natural gas, liquid helium, liquid nitrogen, so on and so on. The various of which, have their own specialized uses, but those will be for another video another time. And it is a small additive to one of the fluoride glass layers of fiber optic cables. Because fiber optic cables, there are actually numerous different glass layers of different amounts of refraction and reflection. It takes a very specific special layering combination to get the perfect retention and transmission of the actual laser pulse signals. And one of those layers is made of fluoride glass instead of silicon glass. Moving on to cerium. One of its most predominant uses comes in the form of the cerium ceramic honeycomb inside of catalytic converters on the underside of vehicles, onto which 3 to 7 grams of platinum group metals are attached or pasted basically at a microscopic level. So the cerium is what's able to hold on to them tightly without reacting with them, and then they, being held by the cerium, take all of the exhaust coming out of the car and detoxify it. Cerium is also very abundantly used for glass polishing or glass repair. It is in those compounds that are injected into the cracks, fill in, and, become one with the separate sides of the glass. Another one of its more critical uses is in the electrodes for arc welding for many modern manufacturing processes, whether it's manned arc welding or whether it's much more large-scale machine arc welding. And it also finds itself in the role of a tiny alloying component of specific high-strength aluminum alloys, most of which find their use in aircraft and vehicles. The idea being, obviously, the stronger you can make the aluminum alloy, the more steel you can replace with that aluminum alloy, and thus the more fuel efficient the vehicle becomes. And it is also used, along with lanthanum, for flints and flinting surfaces, like the spark on a lighter, or just a regular flint and steel set. Samarium, mentioned before. It is used in electric motors as well, however, it is primarily specialized to small electric motors, the type used in things like shaving razors, small toys, the tiny little ones inside of your phone that allow it to have the vibrating effect, the ones inside of cars that roll down your windows. Anywhere there's a motor being used, if it's really small, then most likely it's samarium instead of neodymium. And it is also used as the resonator magnet for sound equipment, from headphones to microphones to phones themselves. And more recently, it has been finding a growing use in many new cancer-treating drugs, where, previously the only thing we could really do was just irradiate you. But now we've actually been able to come out with so many specific medications now that very specifically, narrowly target the cancer cells themselves. And samarium is also being used as one of the catalysts in many detoxifying compounds for detoxifying lakes and water supplies, and in many of the breakdown compounds being used for many cleanup efforts to break down things such as plastic in the environment. Yttrium has quite its wide array of uses. It's blended in small amounts to make silicon nitride, which is the material used for various engine components of different types, namely fuel-air mixers in modern engines, numerous bearings in modern engines as well, and used for numerous parts, including portions of the nozzles of rocket engines. Yttrium is particularly critical to the functioning of radar dishes, that modern thing that allows us to see the sky, in a sense. It is also used in a small component as part of the alloy mixture for microwave shielding. And, like numerous other rare earth elements, it is used in lasers. It particularly finds predominant use in the cutting lasers, and is also predominantly used in the also aforementioned scanning and measurement lasers. And in terms of just lasers in any other use, it is particularly critical for producing red lasers. Not infrared, that's neodymium, but regular visible light red. And it is necessary for the compound known as YAG, or YAG, yttrium aluminum garnet, which is a phosphor used for LED light bulbs. It's coated on the inside of the bulb, as the actual diodes inside are not giving off actual white light. They shine onto the inside of the bulb, and the phosphors glow and then give you what you see as regular white light. And similar to samarium, yttrium is also finding its use in many emerging cancer treatment drugs. And yttrium is a little-known component, at least to most people, of durable, impact-resistant glass. Anything from automobile windshields to bulletproof glass. It is also predominantly used in the mixture of heat-blocking or heat-resisting ceramic coatings used in things such as the furnaces of power plants, things such as firing kilns, and used most commonly around you that you would see, although you won't actually see it because you're hopefully not crawling inside of the engine unless you're an engine mechanic, but used to coat the inside of the combustion and exhaust chambers of aircraft engines. And it also finds itself in various high-strength metal alloys in the same way as praseodymium did, granted in higher concentrations. You can find yttrium usually included in anything from 0.1% up to a solid 2%. Holmium doesn't have too many uses, though the few uses it has are pretty important. Holmium is used for many types of lasers, many different spectra of emission, and it is also one of the key functional materials that allows us to have spectrometers. And holmium has a potential future role to play as one of the materials in quantum computers. Europium is one of the phosphor components added to the glass tubes of fluorescent lights that allows them to give off regular white light. That's one of its predominant uses, although it also finds its use in phosphors and pigments elsewhere. Previously, the great consumer was CRTV screens. However, those are on the way out in most places in the world. So now it's down, similar to terbium, to just being a pigment used in LCD screens. However, again, like terbium, the LCD screens require a much lesser amount of it than CRTV screens. Erbium finds its very special use in the fiber optic communication lasers that actually send the light pulses down the fiber optic cables. It is also used as one of the alloying components for the metals used in supercooling refrigeration. And it is one of the preferred elements for the making of synthetic or fake jewelry. Yttrium, with a Y, is used for gamma ray emitters. It also, like holmium, finds its way across the entire spectrum in the usage of many different lasers of different wavelengths, and also finds its use in transducers as well. And it also, as the field potentially expands, will have its role to play as one of the materials used in quantum computers. Now, lutetium, or at least that's how I'm going to say it, is critical in medicine across the board. It's necessary in PET scan devices. It is one of the phosphors used in X-ray sheets. And it is also one of the rare earths that is being used for many modern cancer treatment drugs. Now, industrially, lutetium is used in the machines that perform lithography, which is what's used to cut, transcribe, and produce computer processors. So, slightly important. Thulium finds its way into medicine as well, as one of the rare earths needed for the X-ray emitter when taking X-rays. It is also used in some very specialized lasers being used in meteorology, as radar is great, but it can't give you everything, and they're now using LiDAR to start getting very specific sight into storm clouds and the like. And thulium is also one of the materials used in radiation dosimeters. Not Geiger counters, but a dosimeter. That thing that looks like an ID badge that personnel will wear that will gradually, change colors the more radiation it's exposed to. Now another one with quite a few uses, lanthanum. Lanthanum is used for special glass, the particular high purity type of glass that's used to make lenses, i.e. camera lenses, telescope lenses, and all kinds of what have you. And it is also used as an additive in the fluoride glass used in the layers of fiber optic cables. And as mentioned previously, it is one of the materials along with cerium used in lighting flint, and along with cerium, it is one of the critical materials in arc welding electrodes. It has a specialized water filtration use. Lanthanum is used in several filtration compounds for preventing the survival and potential growth of algae in contained, controlled water sources. And it is one of the materials allowing us to go much further in medicine and just understanding of biology in general, because it's needed in the many precision sensors for all of our different molecular biology instruments, allowing us to actually see how the various individual molecules and substances interact. Promethium doesn't have too many uses. Its primary critical one is in atomic batteries or nuclear batteries. Again, something primarily critical to and used by spacecraft, unmanned or otherwise. Uranium, it is technically a rare earth element. However, it's used for basically none of the same things. Obviously, its predominant use is for nuclear fuel rods for nuclear power plants. After that, its most predominant use is munitions coating for armor-piercing or armor-penetrating munitions. Thorium does not have many uses yet. However, it is potentially going to be a critical source of alternative nuclear power. And now, lastly, the handful of strategic metals that are not technically rare earth metals, but are often included in with them in listings. Germanium, the true key dopant element needed in the interior glass layer of fiber optic cables to allow them to have the perfect reflection angles. Germanium can also be used for high-efficiency photovoltaic cells or solar panels. Silicon germanium wafers or integrated circuits are used for the monitoring and regulating of wireless communications because they can handle and process information a lot faster than just a regular silicon wafer. Germanium is one of the key materials, along with antimony, needed for infrared or thermal imaging and detection. And germanium is one of the components of the extremely high brightness LED diodes used for vehicle headlights and external lights on vehicles of all kinds. Indium, primarily consumed to make indium tin oxide, the very thin but highly conductive material that allows modern flat screens, LCD and LED screens to actually exist. It's also one of the components of many different types of LED diodes of various different types of light wavelength. It is also, like many of the rare earths, used in various different types of lasers. Gallium, as I usually refer to it as, it is the LED metal. While numerous different types of LED diodes will contain germanium, or they might contain indium, or they might contain antimony or aluminum, you'll notice if you go down the list that the second metal that's a component of each of those diodes is almost always, and I really mean always, gallium. Gallium can also potentially be used in new types of high-efficiency photovoltaic cells, and gallium is also used in the particular types of lasers used in computers as disk readers. And lastly, rhenium. Its most predominant use being as an alloy component in the various types of nickel superalloys used in aircraft engines. Its other uses including use as a petroleum chemical catalyst. It is the other material used in the actual X-ray emitter in an X-ray machine, and it is also needed in spectrometers. Alright, well that's the end of the rare earths and strategic metals list. Hope you guys all enjoyed. If you all enjoyed learning everything, please like the video as always. Also, subscribe if you're not, obviously. If anybody wants to support or help me in real life, my PayPal link is down in the description below. We're actually getting close to 4,000 subs now, so if everyone actually sent a single dollar, that would basically be enough for me to live off of for like half a year, maybe even 7 or 8 months. But I'm never expecting anybody to send anything, let alone everybody. But anyone who does donate anything before some arbitrarily selected time in April, you'll get your name painted on some cheap plastic Easter eggs. But that's it from me for now, so thanks everybody. Here's some other videos if you want to watch them. May God bless every single one of you, and I will see you all around next time.